Okay, we're going to take a look now at bivariate analysis. Bivariate, by definition, two variables. Univariate analysis, one variable. Statistics, that's what we're coming off with our work in Chapter 8 and the things you did in the holiday homework, looking at just sets of scores and measuring things like the mean and median interquartile range and standard deviation from that. Now we're looking at two variables, so two variables x and y, and importantly the relationship between those two variables. Now, so how this will set itself up is typically, so we're looking at data points x, y, and the relationship between them as they change. So the independent variable typically along the horizontal axis, and the dependent variable along the vertical. So independent things like age, time, that sort of thing, and other variables usually along the vertical. So let's say we're looking at, we might be looking at age and height. So age would be along the horizontal, being independent, height depending on age being along the vertical. And as we take in some data, we'd expect that with age there would be an increase in height, and so we would expect there to be what's called a positive correlation between those two variables. So this would represent a positive correlation. Another example, just thinking off the top of my head, might be where your dependent variable here is age again, and maybe along the vertical is golf handicap. So what you'd expect with age is that the golf handicap would come down. So when you're really young, your handicap's quite high. Then as you get older, you get better at golf, and so if we took a whole bunch, I mean, there'd be some outliers and there'd be some this sort of thing, but what we are looking for is a trend, and we're looking for a trend that exists. Now this is quite a loose trend, but we would say here that there was a negative correlation in here, and we could certainly look at the quality of that correlation, and we do that. We look at how strong it is, and in this case here we'd say that's a moderately strong positive correlation. This would probably be termed as quite a weak negative correlation because of these data points here that lie quite a distance away from what would become the line of best fit, which would go in there somewhere and is defined as the line that best matches up or provides the least sort of least squares distance from each of those points. So these are all terms that we'll look at and talk about. This is a really important area when it comes to making looking into the effect of one variable on another, which is a fairly rich area for research, and it might come into play. And the reason we're doing it now is to maybe help you along with your explorations as you get into those towards the end of this term and next term. Okay, so there's some introductory sort of notes there, and you might just want to take those down. I want to have a look now at an example that actually comes out of the textbook, one of the questions in the textbook anyway, and it's on the screen here. We've got age and height, age in this column, height in this column. This is age in months. That's our dependent variable, and height's our in centimeters. So we'd expect a positive correlation here. So just as we did with our other work, we're putting in our headings and in the column headings there, and just filling it out. So this is our XY data here, and these are our data points. And what we're going to do is have a look at the correlation between them. And in order to do that, firstly, it'd be a good idea to go and have a look at through menu 4. No, incorrect. Sorry. Go back into the main page and pick out what's that page called there? Okay, so that's the data and statistics page. So all I did was go up here and click on the data and statistics page here. Just having entered all my information here into a spreadsheet, into my lists page, I'm going to all I do is then go back through the home menu and pick out their statistics page there. And then I'll come down here to the horizontal where it says click to enter, and that's going to be my dependent variable, which is my age. So I just click on age. You can see that points rearranging themselves. My vertical is height, and it'll draw that scatter graph for me. You can see it's almost perfectly aligned in a straight line, so very, very strong positive correlation. Now, in order to measure that correlation, what we're going to do is go back into, oh, it's up here at 1.2, at 1.1. Go back in here, and I'm going to do a calculation, a statistical calculation on that. So 4, 1. Now, this is a 2-variable statistic, so I go in and hit 2 there. My X list represents my age, and my Y list represents my height, and it'll put my results there. Frequency is 1, that's fine. So in it goes. Now let's have a look down the page here. It gives me now a mean of my X's, so my mean age is there. Mean age of 91.2. That doesn't seem to match up. Okay, so I've just gone in and re-entered the information, and my mean has come out at now 50.4, so that looks a lot better. Must have made an error in there. I think I must have had, if I have a look at the information, I must have had my X as height as well, because my 91.2 was repeated down here for my Y mean. So anyway, come across to this column here. This is where my correct information is. My X mean, that's the mean of my ages, 50.4. I come down, standard deviation of ages, n equals 5. Now the mean of my heights is 91.2. That makes sense. But really what I want to focus on here is my R value, 0.99. Now that's my correlation. Now correlation, that's my correlation measure. It puts a number on the strength of my correlation. Now 0.99 is exceptionally strong correlation, almost 1. 1 is a perfectly aligned, perfectly strong, 100% correlation positive between the two variables. So this is almost bang on it. And so that's the measure that's often used in statistics to talk about the strength of a relationship between two variables. So back to my notes page in a moment. We'll just make a couple more notes and we'll be done. Okay, so just a little table here that looks at our R values and then how to interpret that, because you will be asked to comment or comment on the strength of the correlation between two variables based on the R value that you see on your calculators. So let me explain here. Between 0 and 2, so it's in quartiles really, and between 0 and 2.25, very weak. Now I've got absolute value or modulus signs around the R there because obviously we can have positive and negative values. So between 0 and 0.25 and 0 and minus 0.25, we've got a very weak either positive or negative correlation. In the next quartile, weak, then moderate, and then strong, anything from 0.75 through to 1. Obviously, the last example we did was very strong. Okay, that'll do for now. We've got plenty of examples to get on with in the textbook. There's not a lot more to it than that. In terms of what you need to be able to do in this section, I've pretty much covered it there, and we'll just go on and get some practice when we get into class. So I'll see you then.